Hello and welcome back. Today we'll be doing question 7 from the 2020 maths paper. Let's get started. Question 7. Quantiles is a game for a single player. It is played with an inexhaustible supply of tiles, each bearing one of the symbols A, B or C. In each move, the player lays down a row of tiles containing exactly one A and one B, but varying numbers of Cs. The rules are as follows. The player may play the basic rows CA, CB, CC and CCA, CB, CCC. If the player has already played rows of the form RA, SB, T and XA, YB, Z, they may be the same row, where each of R, S, T, X, Y, Z represents a sequence of Cs. Then they may add the row R, X, A, S, Y, B, T, Z, in which copies of the sequences of T's from the previous rows are concatenated with an intervening A and B. This is called a join move. The original rows remain and may be used again in subsequent join moves. No other moves may be played. The player attempts to play one row after another so as to finish with a specified goal row. Part 1. Give 2 examples of rows other than basic rows that may be played in the game. Part 2. Give 2 examples of rows each containing exactly one A and one B that may never be played and explain why. Part 3. Let Cn denote an unbroken sequence of n tiles each labelled with C. Can the goal row C64, A C48, B C112 be achieved? Justify your answer. Part 4. Can the goal row C128, A C48, B C176 be achieved? Justify your answer. Part 5. The goal row C31, A C16, B C47 is achievable. Show that it can be reached with 7 join moves. Part 6. In any game, we will call a row useless if it repeats an earlier row or it is not used in a subsequent join move. What is the maximum number of join moves in a game that ends with C31, A C16, B C47 and contains no useless rows? Pause the video to have a think, and once you're ready, restart to see if you were correct. Let's get started with question 1. Firstly, we'll just give 2 examples of sequences that can be formed. One example is CCA, CCB, CCCC, formed by 2 of the first given row. And then a second example is CCC, A, CCB, CCC, CC, which is formed by combining the 2 base rows. Similarly, for question 2, an example row that cannot be formed is CACBC, since the number of C's trailing the rest of the row must be 2 or greater. Likewise, we can also have something like CCA, CCB, CCC, which cannot be formed since we need a merge to form CCA. However, we would need to not merge anything to form BCC. Now, let's move on to part 3. Firstly, before we move on to part 3, I'd like to look at this particular rule here, the join move. This allows us to take a row, which will denote RST, and a row XYZ, and we get a row R plus X, S plus Y, T plus Z out. This is suspiciously similar to vector addition, and this says that we can essentially solve the rest of this question using linear algebra. From this, we can write down all possible rows. That is A plus 2B, A plus B, 2A plus 3B, where A is the number of the first tile and B is the number of the second tile. I'll explain why I've been talking about numbers of each type of row later. So for the required sequence 64, 48, 112, we can solve to get that A is equal to 32 and B is equal to 16, and then we can verify to see that we can in fact make this row. Similarly, we'll move on to question 4, and we'll see that solving the first two rows gives B is equal to 80 and A is equal to negative 32, which is less than 0, and this is not possible. Therefore, we cannot make 128, 48, 176. Now we'll do question 5. Firstly, we'll solve the first two rows, and then we'll get that B is equal to 15 and A is equal to 1. I'm going to represent these in binary. 15 is equal to 1111 in binary, and 1 is equal to 0001 in binary. Writing these numbers in binary shows us how we can construct our rows. If we take the row represented by B in one join move, we can get to the row represented by 2B, then we can get to the row represented by 4B, and then 8B. Each of these steps only takes one join move. We can then join these previous rows together, and we can get 12B, 14B, 15B in another 3 moves. Then in the very last move, we can add our 15B, represented by this 1111 written next to B here, and we can add this with the singular A, and this should give us 31, 16, 47. We do not need to count the terms 0001 in both A and B cases, because these are basic rows that can be played and are not counted as join moves in the question. Using this method, one can actually determine the lowest number of required join moves to create any sequence, and in this case, 7 is optimal. Similarly to above, where we created the optimal sequence, one can also create the longest possible sequence with no redundant moves. Here we simply add the row B on every single time, and we can also do the same for A, and finally we can join them together. And this creates 15 join moves, which is the worst possible solution in this case. If you liked our video, please like and subscribe, and we'll see you next time for some more fun maths problems. Thanks for watching, and goodbye.